Okay guys, welcome back. Today we've got a Star-Lite AM/FM table radio that I got at an auction about a year ago and just getting around to messing with it. They originally asked 15 bucks for it. I think ended up getting it for $6. And why don't we take a look at this thing and see what it is. It says as is condition, condition unknown, so let's see what we can find out about that, okay? Alright, let's get into this. So it's got two speakers, AM and FM, has automatic frequency control on it, which is kind of interesting. The case is in pretty poor condition, really. It's got a couple of pieces missing. I'm probably not going to do anything about that. I'll probably clean it up a little bit, but anyway, you can see it looks like somebody tried cleaning it and basically removed the lettering that was here. So this is by no means a museum piece anymore. But we'll see if we can find out what's wrong with it and see if we can get it to work. I mean, I'm sure it'll play nice, and it's kind of got a neat mid-century look to it. I think this is made in Japan. Not much left of that sticker. Let's see, this says, alright, Olson Radio and TV Service in West Alabama. I'm going to say that's in Houston. No idea of a year or anything on that. Okay, let's take a look at the back. Alright, it's got an interlock that's been kind of busted here a little bit. I'm not sure what happened there, but they probably knocked it out. And let's see, we've got some tubes here. We got 1, 2, 3, 4, 5, 6, 7 tubes. Connection for FM antenna. Made in Japan. This is made, I believe, around 1964 is the date I have on a schematic for this. So let me get these little screws out and we'll see what we get. It's interesting. Don't know if that needs to come out or not. Yes, it does. You saw the cord fall off, so that's been busted out. Broken out. Alright, first look. Well, we'll see. Let me get this up and we can zoom in and take a look together. Alright, so we've got, back up just a little bit. We do indeed have two speakers. You see 3 ohm, 1 watt, so it'll have some noise to it. Let's see, pretty dirty and grimy as you'd expect. It's got a built-in ferrite antenna. I'm not sure what you do about the FM antenna. We'll look at that in a minute, or in a little bit. It's got a fuse here, that's good to see. I'm not excited about the look of those IF cans. Those look like adjustable slugs. It means fixed capacitors, which means, you know, silver mica disease possibly. I haven't worked on one of these Japanese radios. This will be interesting to see. This is a Star-Lite, as I mentioned. Looking at how the tuning knob works and how I can get this out. It looks like the tuning surface will stay with the chassis when I pull it out. Alright, so let me get these screws out and we'll pull the chassis out and see what we got. In terms of connection to the speaker, let's see, does it have a plug? Let's hope, let's hope. No, but it looks like what I can do is unsolder these connections to get to where we can get that out. So I'm going to need to flip the iron on and we'll get those out. What do you think? Should we just power this up and see if we get anything? I think what I'd like to do is get it out of here first and take a look at the underside and make sure something hasn't like melted down or blown up or something, and then maybe we'll do that. I'll check across the power connection. It is a series string set. As you can see, there's no transformer here. So I'll just check across here to see if I have continuity through the filament string. Then maybe we'll look at plugging this thing in. But first I'm going to pull this out before I do anything else, and so I got to unsolder that first. So I'll bring you back when I've got that unsoldered and I've got the chassis out. Okay, that's the last of the screws on the case. I noticed it's got an interesting washer setup here that has some kind of grommet around it. We'll have to see if that's part of chassis isolation. Alright, I've got the speaker disconnected. The dial does want to come with it, so let's have the moment. We pull this out and see how it looks. Oh, let's do one more thing. Let's pull the knobs off. Let's see. We've got volume and on-off. We've got a 3-position tone control. I believe this is AM/FM automatic frequency control, and this is tuning. And the tuning works pretty well. Okay, so I don't see any set screws, so let's just try to see if these will come off. Okay, let's get those out of the way. Alright, back to where we were before we got all excited. Alright, here we go. Okay, that is out. You take the case out of the way for now. Alright, let's see what we got. Faceplate's pretty clean looking. The black backing plate. It looks pretty clean. You still see the chromate coloration on here. I suppose it's maybe been cadmium plated. It could be zinc, but you can see the chromate like they would do on carburetors and auto parts and things. It's a dip that catalyzes and creates or converts it. Don't know much more than that. Okay, we gotta take a look at the front. Okay, let's take a look at the underside. Alright, the question I'm sure we'd all like to know is this original? Well, since it's been to Olson's repair, unless it was bought from there, I'm assuming it's had some work done to it. So just kind of cruise down the chassis and take a look at what all we have in here. Okay, the power connection comes in. Oh, it's up here. And that's been bent from the blow that it took. I'll see if I can correct that. And there's a fuse. We got our main filter capacitor here, I believe. I don't see any problems offhand. Alright, so let's start to check this thing out. For fun, let's just see if we have any current that will get through here to see if we have continuity through the filaments. I'm just looking for a non-infinity reading here, right? Back you up so you can see. Okay. Place your bets. I'm going to say there's an open filament somewhere. It's got to be, right? There is, indeed. See if this fuse is any good. Huh. Says the fuse is not any good. Maybe it's just covered in junk, huh? Let's do some junk scrubbing. Yeah, I think it's just covered in junk on that. But I think we've got a problem with continuity here. Okay, what I'm going to do is put some clips on this and just rock a few tubes around and see if we can get somebody to wake up. Okay. Looks like this is the rectifier tube. It may not be part of that circuit anyway. Alright, let's start with this one. Don't see anything changing yet. Okay. Only got one tube left after this one. You check the schematic. It could be the fact that fuse is gone. Maybe that's... Well, actually, I think that fuse is okay. Let me get the schematic out and we'll take a look at this. Okay, I have the schematic on this. So this is a Star-Lite model FMW200. And the Sam's has it from 1964. I'll look to see if I see any date codes on here, but I don't know that I will. Looks pretty nice when it's new. Okay, let's take a look at the schematic on here. Okay, we got the power supply section down here. And first thing I noticed right here, caution, one side of AC line connected to chassis. Hot chassis set. We'll have to pay close attention to that when we work on this. Let me bring it back. Okay. Meanwhile, I'll be on an isolation transformer while I'm doing the work here. Alright, so let's see. Yeah. Probably what I ought to do is find out which side goes to the... Where's the fuse? Okay, the other side of the fuse from the cord. Oh, I have to have the volume control. I have to have a switch on too. Missed that. And then, let's see if that helps. That was kind of a rookie mistake. No, that didn't help. Okay. Okay. One of those to ground. .7 megohms. That's too many ohms for doing filament resistance. So it should be connected up properly. I'm still getting a high resistance. So we're going to delve a little closer here, but we'll see what we can get. Okay, that one was affecting the output some. There we go, 193 ohms, 194 ohms. So this one had a bad connection, but we have filament continuity through here. We're going through all these filaments here and coils, and we're having an impedance of 187 ohms. So we got filaments for all of those. Don't know for sure about the rectifier, but we'll check about that in a minute. Okay. Question is, should we go for fire up? Heck, I'm feeling like it. Why not? I have this on isolation transformer. I'm going to bring it up slow in the voltage. I'll step it up through here. That's relatively slow pace. Maybe I'll speed it up for you so you don't have to watch it, but you'll see kind of as it goes up in case something happens. And I'll put a load on the output transformer and we'll see what we get. fact, I'll probably hook up the speakers just so we can hear what we're hearing, so we can hear the hum, right? Okay, let me get that set up. I'll bring you back. Okay, so we're going to go for initial power up. I've got it hooked up to a you know the drill. I've got a variac. I've got an isolation transformer. I have it on a dim bulb. Let me put the dim bulb into the circuit. Dim bulb is in the circuit now. I'm glad I checked that. And for those who've been following, I've also got a 1 amp fuse in my panel, which is down here. Okay, so I'm used the cord that was busted out of the back anyway, so I went ahead and plugged that in rather than using another cheater. I've hooked up the speakers back to the output transformer, and I've got it currently set, variac set at about 30 volts, as you can see right over here on my gauge there. So I'm going to switch it on, and I'm going to track the current if I can. Yeah. Not showing anything right now. So let me just sit there for a bit, and what I'm going to do is I'm going to speed this up, but you'll see it happening very fast speed, and that way if something interesting happens I can slow it down and show you what happened if something does happen. But meanwhile, I'm just going to let it rest a little bit, see if maybe this electrolytic will not just go straight short and blow out my rectifier tube, if it's any good to start with. Okay, so watch the voltage come up as we go. Okay, we're at 100 volts. We should be seeing something happening in terms of at least glow on the tubes. If the filaments are still glowing. I do see glow. I see glow on the tubes in here. Maybe too difficult for you to see. What I'm going to do is take a picture of it and post it right there on the screen so you can see it. Let's see if we can get to where I can see them both. There we go. You can see both of those glowing. I can't see these, but I know I'm getting filament voltage through. Right, so the rectifier may be bad. I don't know. We can see that. I don't see any glow on it. Maybe I do. I see that the retainer clip on it is off. This clip right here is off of it, but you can see glow right there. So I'm getting some glow there. I don't know if I'm getting output voltage though. I have to check the B+. Turn the volume up. Okay, I'm not hearing anything. Let me back you up some. I'm going to try a couple of the positions for AM, FM, and so forth to see if I'm getting any static or anything at all. AM be most likely to hear something, I guess. Let's see, that would be here. Okay, I think I'm in AM position there. Tuning the dial, let me turn the volume up. Make sure I've got my, it just now fell off, and make sure they stay connected. Speakers are connected, okay. Okay, I'm not. Good, we got an interesting repair to do. It's not just filter hum, fix it, and everything's okay. It's got some other kind of problem going on. So maybe we don't have B+. Let me, and I don't see any current going through this at all. Let me check a few things and make sure we've got everything working. Check that fuse again. Well, no, the fuse should be working because I've got glow. So the next thing we'll do is I'll flip this up and get to where we can take a look to see if we've got B+ coming out of the rectifier. So I'll bring you back when I'm done with that. So I've been doing some look at the schematic. Maybe I should have looked at this beforehand. There is not a rectifier tube in here. We have a diode. I don't know, it's not a selenium rectifier, but it's a rectifier. You see it there at item X10. So what we're going to do is, and what I've done is I've confirmed one side here does go through a coil with a piggyback capacitor straight to the chassis. That's the one that has the fuse on it, as you see there. And then over here we do have a coil directly to chassis, sorry, a capacitor straight to chassis. Is that CA6? And then a coil, or C46. Then we hit the switch. I'll probably rewire that when I get around to fixing this. Then we go into a 5-watt resistor, then we hit the diode. And then we've got a couple of voltages we can check. We can check that 140 as it comes out of the diode, and then we can look here if we come through this section right here. We've got a little bit of a voltage divider going on with that 300 ohm 1-watt resistor. So we can check the 125 volts, the 115 volts, and then I'll have to dig around to find where I can catch those other two as it comes past that switch M5. Let's go first with powering this thing up, and let's see if I put 117 at the input, what kind of voltage we're getting at the output of that diode. It should be 140 volts. That point is located, I don't have power onto this yet, is where this red dot is on this diode. Swing you around, hold on to your hat. So the output of this has 140 volts. Then we go through this first resistor, then we catch that other voltage here, and then we go through this other resistor, and then we can catch the other voltage here before we get to the outputs of the switch. So we'll check those real quick. Okay, I'm set up now. Let me go to power up. Let's see, we'll be measuring DC voltage. Let's see. Dim bulb is in, power up. Switch, power on, switch is on. We're pulling 12 watts. Okay, we're going to turn it up some. We'll go ahead and go to test voltage. I'm watching the dim bulb this whole time. We're up to 20, almost 20 watts. Definitely pulling some juice here. My speakers are connected. You may have a blown out audio output transformer. We'll just have to see. Okay, so let's see if we got voltage coming out of the rectifier. And that should be right here. 157 volts. And we should be getting 140 volts. Maybe a little high here. Let me just turn that down just a little bit, but it's interesting. I'm getting 15 watts. I'm still getting nothing on the dim bulb glowing. Okay. So I'm not getting much current draw. There's not much load on that. Like I say, that should be 150 volts. Sorry, 140 volts. I'm hearing hum. Okay, I'm hearing hum. Let's see. That's AM position. Maybe I'm imagining it. Turn it down. Try a different band. That's not it. It's this. This is FM. Okay, I'm not hearing anything there. Yeah, I'm definitely getting hum out of the speakers, so my output transformer is working. Turn it down though. Alright, so let's see. So we're getting B plus out of that diode. We're measuring it here. Let's go to the other side of this first power resistor, and then we're going to see if we get 125 volts there. I'm not getting anything there. Okay, so what could be going wrong here? Should be getting 125 volts on the other side of the 2-watt 150 ohm resistor. That's 150 ohms. Let me check on the other side of it. 155 volts DC. Let me go on the other side of this resistor. Got nothing. That resistor's open. Okay then, let me get another resistor piggyback over that and see if we can get this thing to conduct through. Okay, so I'm set up to check the resistance across this 150 ohm resistor right there, the power resistor that has the first voltage drop, and I'm getting it as being open. So it could be that, I don't know, the fuse apparently is okay, but it could be that this thing drew too much power and burned that wire wound up. I can't tell if it's gotten hot. It looks like it's got a little bit of discoloration in the middle, but not as much as you expect to see, but it's definitely open. So it's 150 ohms, and what I'm going to do is bypass that. I got into my stash of power resistors, and I didn't have 150, but what I've got is I've got a 25. I'll fix that. I've got a 25, a 50, that's 75, and I've got another 75 is 150. Let me get another jumper on there. I only have them hooked together just so they don't fall around. But I'm using these jumpers here to, let me get a different color, to make the connection solid between them. And I'm going to bring the voltage up slow again, just in case I do have a short somewhere, let the dim bulb have a chance to catch it. Okay, so I'm going to have, this is the input coming in from the output of the diode. I'll put that there. Okay, zoom in. All right, so this chain of resistors, 150 watts, ohms. I'm bypassing this, which is showing open. So I've got one lead here, and the lead on the other end of that chain of power resistors you saw, I'm going to put on the other side of this fellow right there, and that goes right here. Power's off. Okay, I know I show voltage over here, but I have the power switch off. All right, so what I want to do is I want to turn on the power slow, just in case there's a problem. I'll watch the dim bulb, and then we'll recheck the voltage at the yellow lead. I guess I can try it right down here, and that'll show whether I'm getting the right voltage past that, and then I'll leapfrog to see if that one's still any good. This next one over. Okay, so I'm going to turn the voltage down some, and turn the power switch on. Oh, we got a voltage drop then, didn't we? All right, we're pulling 8 watts, 7 watts, 8 watts. I don't see anything on the dim bulb again. So I'm going to go ahead and bring it up. Okay. Okay. Here crackling. Here comes the filter hum. We had a blown resistor, didn't we? Now the question is why did it blow? So let's check the voltage on the output of that first power transistor. And we're getting 113 volts. Let me go back and measure the output of the diode now that we're here. Okay, getting 123 volts now. I'm drawing some power. Some current. Let me crank up the variac a little bit to get it back up to the test voltage. It's 117 volts. Okay, so what I'm going to do now is go back over to here, which is the input to that first power resistor. This is the output of the diode, and we should be getting 140 volts. We're measuring 128, so we're drawing a lot of power still. Okay, now let's go to the output of that 150 ohm resistor we just put in. We should be 125 volts here. 117. Okay, we're doing okay. All right, then we'll check the output of the next one, which should be the output of this guy right here, and that should be 115 volts, 120 volts. All right, so that would be, I believe it's right here. $120 volts. Okay, so if we get any reception. This is an FM if I remember right. There's no antenna connected. Let's see if I can. That's tone control.
Who's hungry? You know, maybe instead of they'll go with French fries to feed the crew, we should order lunch.
Around this year.
I'll go back to Mills. Mills as the man, right? Last year, Mills, a rookie, league started a good one against the Texans, actually.
It's getting actually pretty good reception.
And I don't know what you're going to get out of Driscoll, but he started games in this league as well.
Definitely got filter hum.
There's no elder statesman here.
Could probably stand to have some switches cleaned.
The voice of tech.
The rest of us are thinking, man, if I'm just up there trying.
An RBI single with one away in his 3-2 Rangers.
And it would stay that way until the tech.
Oh, that was an awful game to watch.
That Carl Jackson.
Okay, that's pretty encouraging. Okay, we didn't get anything on the FM. Let me go to FM, see if we hear anything at all. Probably not. There's no antenna connected. Let's see, how does that work? Is this the FM connection? I think this is the FM antenna right here. Let's see, can I just hook a cord up to it? Get anything? Maybe.
We rolling into town.
On that foot.
We rolling high.
Try the automatic frequency control. I don't need to go through any further. This thing's a strong performer. Okay, so we've got filter hum. We'll work on the electrolytic capacitor, get it bypassed. Then I want to find out what's wrong with that resistor. I'm going to take it out and check it to see if there's something wrong with it. But then I'm going to check the wattage draw on this. Let's see, it's supposed to pull 30 watts, and I'm currently pulling 23 watts.
Stick to.
Oh, so yeah, I'm still pulling less than 25 watts, so I'm not really pulling a short anywhere. I'm sure the capacitor's leaking. One of the main things I noticed, let me switch back to AM and get to talk so I don't have to worry about copyright.
Here with the Jaguars, although the Jaguars. All right, so what you just said about the Texans at #1 in 2014.
Okay, what I don't hear is any silver mica disease.
Is it Trayvon Walker?
I'll leave this playing for a while to see if it develops. But I didn't hear it on the AM section, and I didn't hear it on FM. We go back to FM.
Ginsberg, Howard Zinn, Edward Said, Maya Angelou, the poets, the musicians, Bob Dylan, the activists,
Lorraine Hansberry.
Lorraine.
Let's go.
It starts with.
So I don't hear any crashing or anything from silver mica disease, which is wonderful. So what I'm going to do is we're going to take a look at that resistor and find out what in the heck went wrong with it, and then I'll see if I've got a replacement for it. And then we'll see if this thing's about ready to go. So I guess there's just something to be said for clean living and organizing some things. You wouldn't think so looking at my workstation, would you? Alright, so we got 150 ohm 2 watt right here. Wouldn't mind if I had 5 watts. just so it has a little more headroom. But let's see. Let's see what we get here. Yep, Omite. I had gotten a whole bunch of these a while back. They were in cardboard cases that were all falling apart. So I took them all out and put them in Ziploc bags. But you can see right there, 150 ohms, 2 watt Omite. Let's see how we do. Yeah, just to be sure, I lifted the lead on this suspect resistor, and it's definitely open. So we'll finish getting that one out, and we'll substitute it with this one. $150 ohms. Yeah, so as you can see, this thing is wide open. And you know, looking at it, does it look like it got hot? Maybe a slight amount of browning around the midpoint of it. But it sure as heck burned out, or burned open. I don't see any real sign of damage to it. But it's dead open. Okay. So I'm going to bring on the power, and this is not being used right now. We're going to check to see how this works. Bring on the power. So I'm going to turn the switch on, and then I'm going to turn the power on to the variac. Here. And I'm watching the dim bulb to see if I have a problem. All looks okay. Still no glow. Let's see. Power draw is still okay. Yeah. Pulling 21 watts. Here comes the hum. Okay, so we're still getting noise out of it. Still need to clean that switch. And let's see.
Are you kidding me? They've never unboarded
the company to,
This thing has great sound.
to, adjust those caps down lower. So they can say, well, you can only have a max of 3 to 5% even.
Yeah, my only concern still, and it's my same concern with other funds that claim good, decent exposure to cryptocurrency, is just, at what level do you actually have the exposure to the Bitcoin? Because, if they're directly...
Okay, we should be getting 140 volts, I think, out of the rectifier. Yep, I'm getting 126. Then past that new power resistor, I should be sitting at 125. I'm at 115. And then after that one, I should be at 125 volts. I'm looking right here. I should be at 125 volts. And I'm getting 103. So I probably am getting a lot of leakage past that electrolytic, because we know we're getting hum.
They were going to...
So that may be me too. So anyway, now that I've verified this fix is working okay, I'm going to see about bypassing that big electrolytic filter capacitor, and then see if there's anything else I really need to do to get this thing ready to go. By the way, in terms of the hot chassis, one of the things I noticed is that where those screws go into the bottom, it actually goes into these plastic grommets that are here. So strictly speaking, there is not a connection to the screws to the outside. So it does have some insulation. These are not touchable from the outside. They got plastic knobs on them, and there's no metal connection to the outside. So it'll be okay. Anyway, and then the other thing I'll need to do is hook up the wire over here on the far side. You can't see it, but hook up a new FM antenna wire. I just wire where this one goes, comes up, and give it a coil or something for them to use. So anyway, let me tackle how I'm going to get onto that filter capacitor next. So I believe what I'm going to do is I'm going to drill a hole right there. So I've got, just so you see, this is a 3-section capacitor, 40 microfarads each. So each one of these red leads is one of the leads to the capacitors. This goes to the ground lead that's here, and you can see right here Let me show you a little better. This side here goes to the fuse. The other side of this actually ends up this twisted wire that you see here, and that ends up going to the chassis ground, which is back behind this black capacitor, which is right through here. Okay, there's a chassis ground there. So I think what I want to do is I think I want to drill a hole. Now you see there's the chassis is open here, so it's not like I'm creating an RF leak or anything through here. So I think what I want to do is drill that hole, mount it with a screw here, and then I'll have on here I'll have one lead for the grounds to tie on right here. That'll be bolted to the chassis. I may go ahead and run a jumper from there over to the other ground wires just to make sure it's all connected very well, because I'm not going to try to solder to the chassis. And then each one of the capacitors will be loaded onto these other three lugs that are here. And then I'll put that on here. So when I get all that done, I'll bring you back. Okay, so I've gone in and I've put in the new filter capacitors. I left this one in, but it's completely out of the circuit now. It's ground connection still there, but all the other sections of it are out. And there's supposed to be 40 microfarads at 150, and I've replaced it with 39 microfarads at 250. And this is A, B, and C. And they're, once again, they're attached with there's the screw that has it coming through the other side where I drilled the hole. And then over here you can see where I've soldered it in to the different connections. So this is my new ground connection from the grounds of the new capacitors over to where the ground went to the chassis over here. And then I pulled this power resistor away from this lead down here and pulled it over here, and then brought over the other lead that needed to go off to the other locations. And there's other new power resistors in place. So let's get this thing powered up and let's see how it does. Power on. And we're pulling 24 watts, 25 watts, 26 watts. I still haven't cleaned the potentiometers and the switches. I need to do that.
We know. We felt that way too. And that's why we did something.
Too soft. I seep on my left side, move around a lot, and this really works for me. Just go to helixsleep.com/PAGS, that's P-A-G-S, to take their 2-minute sleep quiz. They're going to match you to a customized mattress that will give you the best sleep of your life. They've got a 10-year warranty.
I don't have a, let's see, let me find get an antenna hooked up for FM. Let's see, that goes here.
The company Hunter Biden was on the board.
Okay, so we've had this on for several hours and it's working just fine. And so it's time to start the alignment process. We've got the alignment instructions right here. So we're going to start with the AM side. I've got the vacuum tube voltmeter here. It's been warming up for a bit.